Hey guys, this is the 14.3 video, and first we'll be working with this integral, the double integral over the region R, x plus y dA, with R being enclosed by x squared plus y squared equals 16, x is greater than or equal to 0, y is greater than or equal to 0. So first we want to convert this integral to have a polar setup using x squared plus y squared equals r squared, which means that r is going to equal the square root of 16 from this up here, which equals 4. And our theta will be pi because we only want the portion above or equal to the xy plane from these two things right here. Therefore, our integral setup, which is all we're doing, we're not finding the actual integral, is going to be from 0 to pi, 0 to 4. This is your r's, this is your thetas. And x is the same as r cosine theta, and y is the same as r sine theta. dA is r dr d theta. And since that one was simple-ish, it was one of the easier ones. I'm going to move over here. So we're going to find the integral 0 to pi over 2, 0 to 4 cosine theta, r sine theta, dr d theta. So right here, we know that we're going to be integrating with terms of r first, which is going to give us r squared over r times sine theta, evaluated from 0 to 4 cosine theta, and all that's going to be over 2. And the 0 is just going to give us a 0, so we only have to worry about our 4 cosine theta, which squared is going to be 16 cosine squared theta over 2 is going to be 8 cosine squared theta, which is what I have down here. So now we have the integral from 0 to pi over 2 of 8 cosine squared theta sine theta d theta. And here I use u substitution, with u being cosine theta and du being negative sine theta d theta, which means that this sine theta is basically going to get canceled out in a way, and that this over here will be negative, which I'll show in a minute. And converting our limits of integration, we have that cosine 0 is 1 and cosine pi over 2 is 0. And integrating u, or 8u squared, we have, and this is negative, remember, so negative 8 over 3 times u cubed, evaluated from our new limits of integration, 1 to 0, gives us negative 8 thirds times negative 1 equals 8 thirds. Now I have to actually erase and go to the next problem. Oops. Our next problem is the integral from 0 to 3 to 0 to the square root of 3 minus y squared of dx dy. And we're wanting to convert this to polar first. So converting this to polar, we see that our radius will be, this right here is the same as, since we're doing x first, this means x equals the square root of 3 minus y squared, which means x squared plus y squared equals 3, which means that r equals the square root of 3. So r will go from 0 to the square root of 3, Also in the question, we're just wanting the top half, which means we're wanting, anyway, we're only wanting to go from 0 to pi, so our trace is going to be like this. That's going to be our trace. Anyway, we're going from 0 to pi. Which you can get from this actually. You see that it only wants to go from 0 to 3. So like this way, we're wanting to go from here. So like here, which only gives us a certain portion. R dr d theta. So evaluating from here, we have the integral from 0 to pi, r squared over 2, so that's going to be 3 over 2, and then 0 squared over 2 is 0, minus 0 d theta. So then we have 3 over 2 theta evaluated from 0 to pi, which gives us 3 pi over 2. This is a pi. The next problem's a little bit better, and I'm just going to sit down and write it beneath. So we want to find the solid, or find the volume of the solid. Enclosed by the ellipsoid. X squared plus y squared equals 9z squared plus 9z squared equals 9. Okay. So our integral set up, we're going from 0 to 3, because if you plug in 0 for z, then you get x squared plus y squared equals 9. So your r equals the square root of 9, which is 3. So 0 to 3. And then we want the whole thing, so it's going to be 0 to 2 pi of the square root of 9 minus r squared, because, and this is going to be over the square root of 9 r dr d theta, because solving for z, we get that z equals the square root of 9 minus x squared minus y squared all over 9, like this, which is the same as this, and then we can just move a 1/3 out. And I personally like working like this. Is going to end up giving us a number we don't really like. So what I'm going to do is make this negative right here. Make this still be 0 to 2 pi. But now this will be 3 to 0. And if you don't know what just happened, again, review properties of integrals. And now we have the square root of 9 minus r squared. And doing u sub, we have u equals, and this is r dr d theta. U equals 9 minus r squared. Du equals negative 2r. So that's going to make this negative positive, and it's going to be getting rid of this r, and it's going to multiply or divide by 2, so this 3 becomes a 6. And all of that's going to be for our u. This is still going to be 0 to 2 pi, but we're going to have new limits of integration. This is going to be the square root of u d theta. So our u's are now going to be u equals 9 minus 3 squared equals 0, and u equals 9 minus 0 squared, which equals 9. So it was going to be 0 to 9 from here. So we're going to have 2/3, so 2 over 9. I multiplied it by that 1/6. 0 to 2 pi of u to the 3/2 evaluated from 0 to 9 d theta. I'm going to hope you can get further than that on your own, because I'm running out of video time, and really from here on it's just a single integral. So good luck with this. I hope you do well on this section. See you in the next video.